All right, hello class. This will be the solution for Thanksgiving break handout. All right, uh, this, as you can see on the top left corner, you will see the question, which corresponds to the handout questions that I've given you. Now let's look at the first question. A particle moves along the x-axis such that, so this is in fact position, and then velocity, and acceleration question. So they were asking us to find the velocity and acceleration. So let's try to do the first one first. So we have velocity, v of t. We know that velocity will be in fact uh, derivative of this. So in fact derivative of sine becomes cosine of e to the t. And through the chain rule we have to multiply by e to the t, because e to the derivative of the e to the t will be e to the t itself. So that will be, in fact, first part of the answer. Second part, acceleration, a of t, in fact, will be derivative of the velocity. Since we have two functions multiplying together, as you can see, we have to use the product rule. Now, let's go for the product rule then. First, we're going to take the derivative of the cosine. That means negative sine of e to the t, and derivative of the inside, which is e to the t itself. But we have to multiply by e to the t, which was already there. So we, in fact, we'll be getting e to the t. Now, let me just point out to you that from here to here, what's the derivative of this portion of the function? Now, let us go for the second one. Here, adding on to, since we took the derivative of this one, we need to take the derivative of this and multiply by that. But in fact, you will realize that that is the same thing. There it goes. We answered A. B. At what time does the particle first have zero velocity? Now, that means in order for us to answer B, we just have to set v of t equal to 0. That means, when do we have cosine of e to the t times e to the t will be equal to 0. Now, you will realize that e to the t will never be equal to 0 as long as t is the real number. Now, that means only way that would be possible is we could set cosine of e to the t to be equal to 0. And we realize that this is possible if e to the t will be in fact equal to pi over 2, because we know that cosine of pi over 2 is equal to 0. Now let us continue. I'm going to leave this, I'm going to put this one in the box because we're probably going to be using this one continually, but this means t will be equal to, by taking the natural logarithm on both sides, ln of pi over 2. That would have been our answer for B. At what time does the particle first have zero velocity? When t is equal to ln of pi over 2. Now let us try to go back to answering C. Now C is asking, what is the acceleration of the particle at the time? Now, you're looking for acceleration. As you know, acceleration, a of ln of pi over 2. Now, this looks somewhat complicated to plug in, but in fact, you'll realize that since e to the t power is equal to pi over 2, that means we can apply that right here, right here, right here, here, and here. Haha. Then we end up getting something like this. Negative sine of pi over 2 times pi over 2 squared, because we have two of those right here, e to the t. Now, plus, oh wait a minute, you will realize that this portion, when you plug in this value in, this portion is equal to 0, because that's how we set it up, as you can see right here. That means our final answer for the acceleration will simply be, while this one is equal to 1 with a negative sign, so we end up getting negative pi squared over 4 would be our acceleration. So there it goes, the first question. Yeah. Let's go for the second question. Same kind of question here. Particle starts at time t equals 0, move to number line. Now, once again, we're talking about position. Oh, it has to move to the right. Moving to the right, in fact, implies that velocity is positive. And particle at rest, in this case, velocity is equal to 0. Now, when does the particle change the direction? This is where velocity goes from positive to negative, or negative to positive. So we'll try to look onto this one together. Now let us realize that the position function is given in this way. Then what is the velocity function? As you can see, you probably have to use the product rule here. Then we get to realize, hey, t minus 2 to the third power, and let us multiply by the derivative here, which is simply equal to 1 plus. Now let us take the derivative of the first one, which will be 3 t minus 2 squared times the derivative of the inside will be in fact equal to 1 times t minus 6. Now as you can see here, we realize t minus 2 is common. That means as you factor t minus 2, in fact the lowest exponent here is equal to 2. Common exponent is 2, so we're going to factor out 2. That means we are left with t minus 2 plus 3, and then t minus 6. Now let us simplify this one further. T minus 2 square, and we will realize that this becomes 4t, and then this becomes 18, while this one becomes negative 2, so we end up getting negative 20. Now, just for the argument's sake, let us simplify this one further, and then I'm going to take out 4 remainder 5. Now, given that, then here, when do we have v of t greater than 0? Now you can sketch this one if you want to, but by looking at this, if you remember from pre-calculus, we can actually use the number line, and you will realize that when t, this will be equal to 0 if t is either equal to 2 or 5. So I'm going to put 5 right here, 2. And then you can plug in the values where t is less than 2, or between 2 and 5, or greater than 5. Now, just one hint that I can give you is that if you remember from the double root idea of this polynomial function, essentially, is that about the double root, the signs will not change. But about the singular root, it will change. If you have that idea, then you can get the answers rather quickly. But we're gonna, in this case, we're gonna try to do one at a time. And then I say this is section number 1, section number 2, section number 3. And of course, each number will be when t equals 1. We're going to use that as a test value. And t equals 3 as a test value. I'm just picking any number within that context. And then since v of 1 will be equal to 4, and then 1 minus 2 squared, and 1 minus 5. So as you can see, I'm using this function right here. And you will realize that this portion is simply equal to 1, hence we end up getting negative 16. So here, we get to realize the sign is negative, meaning the particle is moving to the left. Let's look at here. Based upon our theory before, since it's a double root, we should be getting the negative value here also. Well, let us see what happens. Now, when v is equal to 3, v of 3, and t is equal to 3, so we get 4 times 3 minus 2 squared, which doesn't make any difference, and then 3 minus 5, this is where the difference comes in, and we get to realize that that is equal to negative 8. And once again, we get to see that the values here are negative. Here, because of the change, a single root, then we will end up getting positive, but we'll just check upon it just in case. That's b of 6. That means 4 times 6 minus 2 squared, and then 6 minus 5. Once you calculate this one, you will get 64. That means this is equal to positive. Now, in fact, as we do this, we answered a few questions already. So first, when is the particle moving to the right? Our answer, well, that would have been right here. So to answer part A, the answer is when t is greater than 5. That would be our answer. For number B, when does the particle at rest? That's when t is equal to 0, which means when t has to be equal to 2 or 5. Now, let us try to answer C here. When does the particle change its direction? You will realize that the particle changes the direction when t equals 5. So, when t equals 5. There it goes, guys. We answered all 3 questions, in fact, with this number line. So maybe I should highlight that. That's very important, people. Let's remember. All right. And then I will continue on the part 2 of the review. See you later.